Hello, children. Let's discuss some important terms of laws of motion, class 11th. The terms which we shall be discussing in this video are mass, weight, gravitational and inertial mass, impulse, impulsive force, and frame of reference. Let's start with mass. Mass is the amount of matter contained in a body. It is a constant quantity and it is a scalar. It obeys the rules of arithmetic. The SI unit of mass is kg, kilogram. Mass is an inherent property of an object. It is independent of the object's surroundings. Mass does not depend on the method used to measure it. Mass measures inertia. Mass is measured using a common balance. Let's discuss another term called weight. Children, do you know what is weight? Weight is the force with which a body is attracted towards the center of the earth. If the mass of a body is m, then its weight is W equal to mg. As the value of g varies from place to place, so weight also varies. Weight is a vector quantity. It is measured by a spring balance and its SI unit is Newton. The practical unit of weight is kilogram weight. Let's start with new terms: gravitational and inertial mass. The mass of a body, which determines the gravitational force of attraction due to Earth, is called gravitational mass. Inertial mass. The mass of a body which measures its inertia is called inertial mass. It is proportional to the amount of matter contained in the body. Inertial mass is measured by the ratio of the force F and the acceleration A produced. Inertial mass is conserved during chemical reaction and is not affected by the presence of other bodies near it. Inertial mass varies with velocity. Inertial mass is independent of the size, shape, and state of the body. Children, do you know inertial mass of a body is proportional to its gravitational mass? Students, when the body is in the influence of gravitational force, then we use here small g, that is acceleration due to gravity. The formula for finding inertial mass is F equal to ma. The formula for finding gravitational mass is mg equal to F r square over gm. For better understanding of gravitational mass, children, you can refer to the chapter of gravitation. We can measure inertial mass by an instrument known as inertial balance. Let's start with a new term called impulse. Impulse is a measure of the degree to which an external force produces a change in momentum of a body. It is not a property of the body alone. The product of a large force and the small interval of time for which the force acts on the body is called impulse. It measures the total effect of force. The SI unit of impulse is Newton second and the dimensional formula is mLT minus 1. Impulsive force. A large force acting on a body for a short interval of time is called impulsive force. Such forces cannot be measured directly, but we can find their value by knowing change in momentum. Some examples of impulsive forces are collision between a hammer and a nail, bat striking a cricket ball, the punch of a boxer on the face of his opponent. This force is much greater than that of force of gravity, so it is called as impulsive force. The condition for a force to be called as impulsive force is that it varies with time and act only for a short time and must be much greater than any other force. Children, I hope you have got some idea about the terms which we have done. Now let's start with another term, frame of reference. To study about the state of rest or motion of a particle, first we should specify its position. The position of a particle is specified using a system of three mutually perpendicular axes OX, OY, and OZ. Here O is the origin. This coordinate system is called rectangular Cartesian coordinate system. It is also called a frame of reference. There are two types of frame of reference. The first one is inertial frame of reference and the second one is non-inertial frame of reference. A reference frame in which Newton's first law is valid is called an inertial frame of reference. It is also called Galilean frame of reference. In an inertial frame of reference, a body at rest remains at rest and the body moving with constant velocity remains in uniform motion if no net force acts on it. Thus, Newton's law is valid in the reference frame. A girl standing on a terrace is in inertial frame of reference. A bus moving with a constant velocity is in inertial frame of reference. The frame of reference in which Newton's laws do not hold good is called non-inertial frame of reference. All the accelerated and rotating frames are under non-inertial frame of reference. In an accelerated frame, even if no external force acts on a body, it will appear that a force is acting on it. Such a force which does not really act on a particle but appears due to the acceleration of the frame of reference is called false force. Let's take an example. When we consider large masses of air and ocean currents, the effect of Earth's rotation has to be considered. In that case, Earth cannot be considered as an inertial frame. It is in an accelerated frame of reference and hence we can say it is in non-inertial frame. Students, I hope you have understood the terms of laws of motion. Thank you for watching this video.